But anyways, we'll start with, I have a list of questions that I want to ask. Um, but feel free to ask any question in between. Maybe if Zafir can answer, maybe he'll answer it. If not, maybe we'll try to figure out uh, answers to that, maybe, and then I'll try to post, or maybe Zafir will try to post about it. Right. My first question is around um, the concepts that we want to understand. What are the important concepts, that help um, somebody like me who's not in AI, and I'm sure there are quite a lot of people who are not in AI.
Yeah.
What are the things that would, fundamentals like people should understand, and what are the things people should understand about the workloads, AI workloads? How do you run it? How do you plan it? So, how does that work?
Yeah, sure. I've seen your questions, so I'll try to answer like most of them. So starting with like last year itself, like until last year we were only hosting CPU based workloads inside our Kubernetes, right? And if you see the CPU based workloads in Kubernetes, the C groups and the Linux kernel will decide like this much CPU and this much RAM will be allocated to this particular pod, so that becomes easier, and it's like a native functionality that is supported by the Kubernetes. But as soon as you come to the AI workload, things gets little changed, as Kubernetes doesn't natively supports AI workloads. You can't schedule like I need this much amount of VRAM to be used in a pod, or this much amount of CUDA cores to be used in a pod. Just to be clear, like so everyone is on the same page, the way you have CPU cores and the RAM for the CPU based compute units, on the similar lines we'll have CUDA cores and VRAMs on GPU based workloads. So this is how the things changes. So if you are scheduling a pod inside a Kubernetes using just a CPU based workload, it's very simple. You can define the resources limits and the request, and you can spin up the pod. But as soon as you go to the GPU based workload, there is an additional thing that you need to have it pre-installed or pre-set up. That is the daemon set specific to the GPU that you are using. So, for example, if I'm using the NVIDIA GPUs, all of my machines are having NVIDIA GPUs. So, NVIDIA, as soon as you install the Kubernetes cluster, or already you are having a Kubernetes cluster, you need to install the plugin that lets the kubelet know, okay, this many devices, these many GPUs are available inside all the nodes. So, what it does is basically it does few things. One is as soon as you install the NVIDIA daemon set, it will run a pod on every node, and it will try to connect with the host drivers and will try to find out, like figure out how many GPUs are there in specific node. So let's say we have three machines A, B, C. So A is having one GPU, and machine B is having like two GPUs within single machine, and machine C is having not even a single GPU. So um, these GPU pods will just communicate with your kubelet, and they'll let you know, okay, these are the resources that I'm having, right? Now comes the next part. Now, if you want to schedule a GPU based pod, what does GPU based pod even means? It means the way, if you're running a GPU based workload outside of Kubernetes, the same way you want to run it inside Kubernetes, right? So, for example, if I want to do the LLM inferencing, or if I want to host an LLM, or if I want to train an LLM, or you want to train the model training using computer vision, such models, if you want to inference the computer based vision based models. So all these comes under the which uses the GPUs under the hood. So what you need to do is like while creating the pod, you will r- define the resources, additional resources, that you will say this this particular pod will use the NVIDIA GPU, and now here you can define how many GPUs it want to use. So there is a difference. The one difference that you will see directly here is like if you are defining the resources inside Kubernetes for CPU based workloads, you'll define how many milli cores or how many cores or how much RAM you want to allocate. But with the GPU, with respect to GPU, it is different. You will allocate how many GPUs you want to allocate. Not like you can't fractionalize by default. We'll get to the point like how can you fractionalize as well, but you'll allocate the whole GPU to a specific workload, right? So going back to our, the initial setup that I told, machine A, B, and C. So if machine A is having two GPUs, so at max you can give two GPUs to a single pod, and it will use the two GPUs at once and will spin up the pod. If you are requesting for three, but there is not a single machine which is having a three GPUs, there it will go in pending state because you are not actually having three different GPUs on a single node, so that will fail. So hopefully that answers your questions.
Well, it does, part of it, but very insightful information. We are not really, especially me, I'm not aware that we may not be able to split what is required in terms of GPU. I was still thinking like we could, somehow ask for some portion of GPU, and then
Yeah,
it's technically you cannot go for milli-cores kind of a stuff. You have to aim for one single GPU and
yeah,
two GPUs kind of stuff. But which makes things very complex, isn't it? Like, because if you have a pod and if can use only a single GPU, and single GPU is way too much for
right,
some certain pods, and
right,
ha, using those resources, unused resources, kind of becomes a challenge, isn't it? I mean, like, is it one of the
right.
challenges that you also face?
Yeah, yeah. Obviously, this becomes like the first challenge. In fact, I'll tell you what we were trying to add in our product. We were trying to add the Jupyter notebooks inside our product. So the first challenge, we in a testing environment, we just had three nodes, and the notion was any user can come up and spin up the Jupyter notebook, and a Jupyter notebook could be based on TensorFlow with GPU or CPU, and PyTorch with CPU and GPU, right? So as soon as he chooses the GPU part, we had to allocate the whole GPU to that particular pod. So it means if I'm having 32 GB VRAM, the whole 32 GB VRAM is allocated to that particular pod. That restricts me that even if somebody is not even using that pod, like for if they are just using 200 MB of VRAM or 500 MB of VRAM, the rest is being actually wasted, right? And for that purpose, we researched a bit and we got to know that there are other frameworks that lets you actually fractionalize the GPU. But before going there, these are like third-party frameworks which are not part of the NVIDIA ecosystem. But if you have a specific GPU, specific NVIDIA GPUs that actually inherently supports the fractionalization of GPU, that is called multi-instance GPU, that is MIG. So if you're having a specific GPUs like H100 or H200 or A40s or A100s, right? Not A40s, A100 or H2, H20, H30. All these GPUs are actually supporting MIG, which is which what they will do is like maximum you can create 7 instances out of it. So let's say if I'm having A100 with 80 GB of VRAM, I can make 7 fractions of it. That means each fraction will get 11, 12, or 13 GB of VRAM. This is like the official part. And when you're actually fractionalizing the GPU, there are multiple ways to it. When you are fractionalizing in here, it is like complete isolation. If you're fractionalizing using MIG, so what it does is like you will get the separate CUDA cores for this instance. So just to take an example, 80 GB is a VRAM total, and you have made 7 fractions out of it. That's the max you can do with NVIDIA GPUs, only the supported GPUs. So each instance is like 12 GB or 13 GB of VRAM. Now, this instance will have its own CUDA cores, that is like your compute unit for GPUs. It will have its own cache. So you get the complete isolation. So it's not like context switching or something. Even if somebody is trying to use it, they cannot. That's like completely isolated compared to the other ways of doing it, right? So this is one thing. So just to summarize the whole thing, you cannot actually fractionalize beyond 7 instances. Second, not all the NVIDIA GPUs actually support this fractionalization. Even now, if you are going with the other GPUs like AMD or Qualcomm, I don't even know about it. Like, do they support multi-instance GPUs or not? I'm not sure about it. Right. This is the first thing. Now, let's say you're have now the next challenge that came to us was like the GPUs we were having in the testing environment, they were not even having like they were not supported by MIG instances like NVIDIA MIG, so we can't create fractions for it. So we had to go with the third party frameworks. We got to know about two frameworks. One is Tensor Fusion, another is Hamai. Hamai is actually supported under CNCF, Cloud Native CloudFront organization. So, but we went with Tensor Fusion, and there is a reason for that as well. So, what Tensor Fusion does it, the way you fractionalize a CPU like 200 millicores, the same way you could also fractionalize the GPU as well. In fact, it allows you to even fractionalize the CUDA cores as well. So this much amount of VRAM, 7 GB VRAM or 1 GB VRAM or even 500 MB of VRAM you can allocate. At the same time, you can say 200 milli cores of CUDA cores, 200 or 300 milli cores of CUDA cores. This way you can allocate. Hopefully that
So,
answers.
yes, it does. Zafir, we are using some terminology which not everybody are aware of, especially me. We are talking
Yeah,
about CUDA. What is CUDA? And when we are talking about H100, I think it's a kind of GPU by
exactly.
NVIDIA. So it's a
Yeah,
very expensive one as far as I know. I
yeah.
understand that. Can you elaborate on what is CUDA and what is the association with the AM/ML workload and Kubernetes and CUDA? How do they interlink?
Right. So basically, GPUs in general, when we talk about, we talk about two things: cores and VRAM, right? CUDA specifically is a terminology that is used by the NVIDIA GPUs. So if you are talking about the NVIDIA GPUs cores, we say CUDA cores because CUDA itself is like compute unified device architecture. It is having its own ecosystem on where you can directly access the cores of NVIDIA GPUs and program it, right? So I'll just give you one example. Um, I think you might have heard of CUDA programming. Have you?
Yes, yes,
Yeah.
I did.
So CUDA programming lets you directly communicate with the cores that are defined by the NVIDIA. So they just work specifically with the NVIDIA GPUs, not with the other GPUs. So when I say CUDA cores, I mean cores which are cores of the GPUs which are manufactured by the NVIDIA. That's the thing.
Interesting. Now, let's get back to the actual topic now. Mm, I mean, like, how do you differentiate running Kubernetes? I mean, like usual traditional apps where you require CPU, GPU, and a traditional three-tier architecture versus running some AI ML workloads. How do you differentiate? And what is the difference? What kind of skill set is different when you're managing both of them? Can you
Right.
elaborate?
Right, right. I would say few things. Like one is you should be able to run the same workload on like without Kubernetes. If you can, you should be easily able to work the same thing inside Kubernetes. It won't really make a lot of difference in terms of managing and all. There are a few challenges that comes. One is like if you want to distributedly, I mean, this is the first challenge that I talked about. That is the fractionalizing of GPU of the VRAM, right? The second challenge that we faced was like we wanted to train a model, but using the GPUs of all the 3 4 machines which were available. You get it? So let's say I have one machine 24 GB, another machine 24 GB, another machine 24 GB VRAM. Now I want to utilize the GPUs of all the 3 machines, and now I want to train a specific model, right? So, and for that purpose, you need to the way you do in Kubernetes. Even Kubernetes doesn't support it natively, so I think you use Kuberay or something like that, or specific alternate to use the compute of multiple machines. That's where the challenging part comes in. And the challenging part is more of for a specific framework you need to use specific thing. For example, if I want to train the model using PyTorch framework, and if I want to train the model using TensorFlow framework, and I want to use the GPUs of multiple machines, so I need to code it first with PyTorch framework, and then let's say I want to train it using TensorFlow framework, so I need to use the workloads of TensorFlow, and then further use the GPUs of Kubernetes. That's the thing. So ideally, just go back to your question, like getting back to your question, you don't you won't face more challenges hosting an AI workload if you could, and if you have optimized your whatever AI workloads you are running outside of Kubernetes. And once you run it outside of Kubernetes, it's easy to run it inside Kubernetes as well.
Interesting. Let's go a little out of topic here. I'm just trying to understand what was your experience like? How did you get into this AI thing? What were the things that you were reading, and how did you actually practice? Is it like you went into the job right away, or you did some sort of course? How does this entire thing work? I mean, especially for you, I understand that if you can guide people on what is the ideal way of doing things to get into this space, maybe can you walk around your experience?
Right, right. I think our company specifically was, we were mostly working with the computer vision based inferencing and training. Right. This was the first. In fact, I started my internship doing the POCs of computer vision. So it was like doing simple stuff: object detection, object tracking, classification, segmentation. Right. These stuffs I was doing, right? But then we decided to build a product, and that product actually required Kubernetes. So the senior engineers, they decided that we'll use Kubernetes. That will be good architecture for us. So we started with the basic workloads which were not using GPUs, but then eventually then we decided that we'll also integrate the model inferencing inside this product. So basically, let's say I have trained a model, a computer vision based model, which is detecting three to four things: a person, a class, a person as a class, a cat, a dog, and a car. Let's say these four things has to be detected. So, firstly, just to give you intuition, first I'll collect the data set. I'll train the model. I'll annotate it first, and then I'll train the model. I'll say these many images I'm having, so I'll take the base models of PyTorch or TensorFlow, and then after training the model, I'll check the accuracy of it. I'll run on the live inferencing or the existing videos that I'm having. If I'm satisfied with it, then I'll go for the inferencing. I'll say, now my model is ready. Now I'll just use it on the live video. So that's how I went in. And then mostly from AI and ML perspective, I just worked on the computer vision. Now I'm pivoting into LLMs as well, like hosting. One of the operational challenge that we have right now is like we need to host an LLM on multiple machines. So that's the thing. So mostly I'm just learning as the challenges keeps coming. I'm just focusing on it and trying to get the best out of it.
I understand. Any roadmap, like if people wants to get into this,
Right.
anything you suggest, let's say, hey, read this book or maybe go through this course and then you'll kind of get into opportunities, anything of that sort?
Right, right. I think it depends. For if I see it from the outside, I see two opportunities. One is in computer vision, another is LLMs. So if you want to go in LLMs, try to. I can tell I don't have exact resources to utilize it, or I
No,
couldn't tell you at
generalize,
this point. But
generalize, Zafir,
yeah,
and from there people should be able to look out.
right. Right. So, obviously, one prerequisite is like if you want to host a particular AI ML workload inside Kubernetes, firstly try to host the same workload outside of Kubernetes. Try to understand the PyTorch or TensorFlow framework. Pick one of them, and if you're going with the LLMs, try to host the LLMs, train the LLM, fine tune the LLM, and infer the LLM. Start with the small LLMs, And once you exhaust that, try to use multiple GPUs and try to inference the LLM on multiple machines, utilizing the GPUs of multiple machines. And if you even if you do that, then try to host the same LLM inside Kubernetes.
Fantastic. All right, let's move on with whatever we want to do. Um, right, is there any setup changes or let's say when setting up Kubernetes, you have to tweak few things to get the GPU thing working, or is it standard?
Right,
And what are the standard things that you need to have on top of Kubernetes to get the entire thing working?
right.
I'm just trying to understand.
Right. At first place, if you are having NVIDIA GPUs, you must install the drivers, NVIDIA drivers. That is the prerequisite. You need to install the NCC, NVCC library. That is like NVIDIA Container Toolkit environment. These two things, once you install it, now you are in a good position to run the workloads even outside of Kubernetes. This is like the prerequisite. And once you do this, the third thing that is specific for Kubernetes is like you need to install the daemon set of NVIDIA, which is available online. Now, even at this point, if you're not having NVIDIA GPUs or you are having AMD or Qualcomm, you can just search up for the Qualcomm or the AMD daemon set. Now when you install it, as I told you earlier, this will actually let the kubelet know, okay, this is how you have to do it. I'll just add the link in the space so it is easier for you to get it.
Yeah, so that really helps. Um,
Yeah.
so you are also managing. So I'm just trying to understand the role that you are playing. So you are managing the entire cluster and the upgrades. I mean, I mean, model upgrades and all those things that are happening, or is it obviously it is a part of the team? So I'm just trying to understand what is it like you guys do as a day-to-day activity to manage AI workflows and I mean like AM workflows, and what are the challenges that you usually face? I mean like any challenges that you think worth mentioning. If there are nothing, you can just skip. But yeah,
Hmm. Yeah. So, firstly, like day to day work, specifically me, I was not doing Kubernetes for like last 2 months. I was more focused on building CI/CD pipelines, adding HashiCorp Vault Manager, and making Ansible playbooks and Terraform. Right. So I was doing this. Recently, I think last week I started working back on Kubernetes specifically model training part, the AI ML workload. So what it looks like, I don't think like operationally any challenges are there. But if I do remember, I'll let you know.
fantastic. What is the scale of the cluster that we are? I'm assuming that you're going with
Right
a
now,
small.
yeah. Right now we are having only 10 nodes, 10 machines, but we are soon expected to have like around 50 nodes.
Fantastic. I mean,
Yeah.
we hear about these strange things, like, I mean, like, AWS just announced 100,000 node cluster, and then immediately in a month, I guess, right, a week ago, Google announced that they are able to, handle 13,000, right?
Yes.
No, it's 130,000, which is one lakh,
One lakh 30,000. Yes.
30,000.
Yeah.
So we hear about these numbers and we always wonder everybody in the world who are working on Kubernetes manage this kind of clusters. But majority of people that I've spoken to, none of them spoke that they have handled a 500 node cluster, a 1,000 node cluster. Usually it's 100, 500,
Yeah.
maybe 300. It's the range. I mean, like, I
Right.
think if that's the thing, 99% of people who are managing Kubernetes are anywhere in between, 50 to 500. It's only that top 1%, or if not top
Right.
0.1% are, crossing that 1,000 or maybe 2,000, 3,000. Maybe Siam can add a little bit here. I think he must be aware of these things because he's talking to CTOs, CEOs, stuff.
Yes, absolutely. I think that is my question. Is I'm searching for people from the last 2-3 weeks. Whenever I heard the story, I think currently, as of now, as you're speaking, both 130K cluster of the node is the biggest one. What actually the Google announced quite recently, and I'm finding people like who actually managing at least 20,000 to 50,000 node cluster in their real setting. But I usually don't find that kind of a number in a production setting. So it's mostly come from the very big enterprises. I work with a company and we used to have a customer MoneyGram, and they have more than 1200 plus node in their cluster. So that scale I see how much of the burden on the platform and the DevOps team as well. But usually it's very tough to find that niche number of the cluster in there. That's a very rare use cases. I heard people in the KubeCon specifically, I think back in 2023, one of the company I forgetting, they said a story of managing 50,000 node in a cluster. So that is quite rare. I think there might be chances the talk is still available on the KubeCon talk, I think 2022 or 2023. And then I see the trend is moving away from it, managing more cluster. I think back in the day, there's a huge trend in the community of telling people how much of the node they're actually been operating on. But as soon as I think from the 2023 onward, not much of the people's talking about that scale, that number quite often. So it's still for me is also a challenge to see what sort of the workload they have been running on. And also I think in the AI world, what I'm actually seeing uh, in contrast to the things Zafeer is talking about, I think one project that I'm actually really keeping an eye out on is called VLLM and LLMD. Uh, the reason behind this is because AWS, Red Hat, Microsoft, all of the major players are contributor to the VLLM and LLMD project as well. And also I think NVIDIA announces Gravito or something like that. I'm forgetting the name of the project. It's somewhat competitor to the LLMD project. But I'm actually noticing in the industry that people starting to figure out that the wavelength of the LLM workload is quite monolithic, and they're moving from the monolithic framework to the microservices based architecture. So that is where you can run data filtering on some one node, the contextual things on prompt based engineering on this different node, and being segregated between the different kind of a node, and then congest the data into the user friendly way, into the user in a specific pod or in a container. That's I'm seeing is currently been happening. But on the other things, what I'm actually, some people call me out that they said like, some people don't need these kind of AI workload in a production setting, even though they have been very much taken care of, but they don't find a really, real use case in the organization. They still are in the experimentation phase. So that is my worry. Like people are actually moving in a trend without figuring it out. Will this be a need inside the organization? If there is a need, then there is a so much financial setup required, operational setup is being required, and also you need to have a roadmap, because in an AI world, you can't live without a roadmap as well. So in terms of the nodes, from my experience, I used to managing in a team 1200. I hear stories around 20K, 30K, but missing stories more than 50K. That I'm actually figuring it out about. And I think in the near future, in 2026, with the projects like VLLM or LLMD, I don't seem to see a reason that the node are scaling. They should be shrunk, not being, we live in a world where have 100K nodes. So I think those projects have a very niche use cases to bring the cluster down to a smaller scale rather than growing infinitely. Is it happening, or how much time would it take people realize that now we have a way to reduce the cluster size. It's still, I'm actually looking forward to 2026.
Fantastic, Sam. Thank you so much for adding a lot more context than I ever expected. Right. Let's go back to the actual discussion. What are the top operation problems that you face at work? I think it's already something that we already discussed. Are there any
One thing I
specific?
would like to add in this thing, I just remember it. One problem that we specifically faced, that you don't actually face in like compute based workloads, is distributed training. So if you are using the GPUs of multiple machines, so you use actually in real time you need to pass the data between the nodes really fast. So the issue that actually we faced was, if the data is being passed between one machine to another machine in real time, the network is expected to be very fast, but we were not having that high network bandwidth. And this I'm talking about when all the machines were in the same region, same network, and everything is on premise, right? Nothing is on cloud, right? But I don't know, like as and when we will move to machines with different regions, when we'll actually productionize it, where we are expecting at least all the machines won't be in the same regions at the same place. They're expected to be in different networks, although we'll create a virtual private network. But that high level of bandwidth is required for us to actually take the advantage of distributed training. Just to give you an example, one benchmark that I did a few weeks back was, let's say I've hosted an LLM on multiple machines. So if I do a query, right? So what I got to know is like it would take at least 4 minutes to answer that query, because of the network bandwidth that I was having versus what I was expecting. So this is one problem that needs resolution. So this is like the default strategy of hosting the LLM that we were trying to implement. But once we got this challenge, we are now looking for other type of sharding techniques through which we can host the LLM on multiple machines.
So I wonder. I mean, like, which makes me wonder. We are still in the early phases of all these things, and we still have so many issues that needs to be, fixed. And obviously, so much optimization is also required. I'm not really sure if the big companies have figured this out, or do they, completely go with the massive clusters because they have massive, millions, millions, if not thousands of GPUs. They go ahead and do it. Um, any idea on that layer?
I actually have no idea about that. Like
Fine, I
how
understood.
how did they figure it out? Even
I
I didn't,
understand.
like, yeah.
Understood. I mean, like, there are quite a lot of challenges. This is something that is booming up right now. I think there will be so many other issues that will be coming. Anyways, as we discussed, when you are talking about scaling the workloads on normal Kubernetes cluster where you have a traditional three-tier architecture, it's usually based on CPU and memory and all that stuff. How does the
I think I
you know
lost you. I think I lost you. Can you repeat? Sorry.
I'm just trying to understand how does this auto scaling concept work with GPU workloads? And, let's say if there are pods and there is huge number of requests that are coming in,
Right.
how does the scaling part work?
Right. Right. So here I would like to add one more thing, that let's say if we are hosting an LM for inferencing, so by default I know that I need 6 GPUs, or like I need the GPUs of 3 machines, the whole GPUs of 3 machines. So depending on like what I'm expecting, um, And now I did the SLO. I said if the queue or is like it is having 32 requests per replica, or like latency is greater than 200 millisecond, I'll just add a GPU pod, and this GPU pod to actually uh, become active and start taking the request. This takes little more time compared to the CPU pods. Right, it will take at least 20 to 120 seconds of warm up. Right, loading the model, the scaling strategy is, this requires at least like 20 to 100 seconds. So that is the thing. I think we should. What we are doing is like we are always having one extra workload ready, and depending on the query request that you are having, you are scaling it up and scaling it down.
Interesting. The same strategy that usually happens with normal workloads as well. I mean, isn't it? Because I remember seeing a video by the Hotstar guys where
Right,
they said like there is an important match that's happening between India and any other nation. It's a very world-class game. Usually what they do is they pre-launch all these instances before the before the start of the match. And then as depending on the situation of the match, let's say if the match is, highly favorable against India, usually the traffic spikes up from, let's say, 20 million to 25 million, 30 million, and they usually spike the traffic based on the, usage, which means pre-launching is a standard strategy for
right.
both normal workloads as well as GPUs.
Exactly. At least it is required here. Um, we'll see. Like as I told you, like we haven't yet productionized this. This is just working in the dev environment or staging environment. Once we'll productionize it and deploy it like on 50 GPUs, 50 machines, 200 machines, we'll get to know like what other challenges we are facing.
Hmm. So, all right, so we are nearing the end of the session. We just have a couple of more questions. I will try to finish this off in time. Anything that you want to share on the security side of it, like how security obviously is a big gap where AI ML workloads is relatively new to Kubernetes. So any security related things that you would want to add here, especially whatever you are learning, whatever you have implemented, anything that you can share in that line. Hey, you are on mute. Just
Oh, sorry. Yeah. So I'll just share one thing here. I told you initially, right, that we have multiple strategies of fractionalizing a GPU. One is we can use the NVIDIA daemon set directly, and with MIG, which is supported by only few GPUs. That is big GPUs, A40, A100, H200, and all these GPUs, right? If you are using that, you get the best isolation of the VRAM, CUDA cores, and the cache. Everything is isolated. So if you are running a process on it, and you're running a second process on different instance of it, a different fraction of it, these two processes cannot actually share the memory at all, right? So you get the complete isolation here. But let's say you are using tensor fusion or like third party frameworks like hami or tensor fusion. In this scenario, what happens is like they do context switching. They don't completely isolate the VRAM. So if I'm actually saying use 2 GB of VRAM and one CUDA core, or like 200 CUDA cores, right? So what they'll do is like they'll just do the context switching a lot. So two processes are there running on the same GPU. They can actually access each other's memory. So this is the big disadvantage that we actually face with tensor fusion. So we haven't yet figure it out, but we'll speak to them and we'll see, or we'll see like how we can isolate these things specifically like the cores or RAMs should be isolated completely for each process. That didn't happen yet.
interesting. I've also read somewhere that the way CPU works and GPU works is a little bit different, especially in the way the context switching works. Um, CPU is pretty good at context switching. Let's say if you have 100 process, CPU is pretty good at allocating. Let's say if there is 1 second, CPU is pretty good at giving each process 10 milliseconds to each process.
Yeah.
And then it context switch. Let's say if there are 100 processes, it will give 10 milliseconds to process one, 10 milliseconds to process two, 10 milliseconds to process three. It will do context switching with that kind of speed. But it's not that great with GPUs
Right.
because of architectural constraints. I don't know very internals of it, but I
Yeah.
generally know that this is one big problem you have with workloads running on GPUs. But for people who don't understand what context switching is like giving CPU time to one process and then giving the next 10 milliseconds to another process and the next 10 milliseconds to another process. So CPU will not give 100% time to a single process. It always gives some percentage of CPU to process one, process two, process three. If you have 100 process, it manages everything. It's all about management. Anyway, so
Right,
let's
right.
let's
I think you have also heard. I read some interesting thing about this CPU context switching. What it does, it provides a nice value and priority. So let's say if I'm running three processes on CPU, so if a specific CPU process is taking more time than it is allocated, so it will just devalue it and it won't schedule the CPU core to it until for some time. So it is like some sort of ranking and priorities that it sets. So let's say if 10 processes are running, if the first process is supposed to take only 5 seconds, and but it took more than 5 seconds, so its turn won't come like again after 10 process. It will just degrade it or derank it. So it's so basically it tries to uh, schedule all the process fairly, so each process will get decent amount of CPU cores.
That's true. I mean, like if you keep on talking about it, there are so many things that we would want to talk. But anyways, let's come back to the final question. Something that I've already asked. Um, so any specific SaaS on cloud, um, uh, this specific AI ML stuff, do you recommend any specific cloud that we should focus on to understand or learn to get into the industry? Is it like GPU workloads are basically on-premise setup? I understand that from the conversation that we had, you are working on on-premise setups and all that stuff.
Yeah.
Anything on that line? Because I see so many people still use cloud as their primary ways of using GPUs because you'll get access to so much stuff. But there are companies who always prioritize on-premise. So what's your understanding on that area?
Yeah, yeah. So I told you like initially, our work is completely on premise because our clients expect, no matter how big the cost is, they expect like we'll pay for it, but everything should be on premise. The server should be, we will buy the servers. We don't trust the cloud. This is their ideology, strangely enough. But regardless, I think if you want to actually go with AI workloads, one is like if you compare the CPU workloads or GPU workloads are very expensive. I think you might have even seen on any cloud provider if you want to go with, right? I think Bolter does gives you free credits like $200 or other cloud platforms as well. I think like just start with the basic AI ML workload and try to deploy it on Kubernetes. That will give the decent understanding on how you can use the GPUs and inside Kubernetes.
Yeah, on-premise it is. I think I've also heard about it. Most people in the Middle East prefer their workloads to be on their on-premise because of uh, probably country level policies or the
Yeah,
organizational policies because majority of cloud providers um are from the US. So I'm not really sure people are. from the Middle East are comfortable sharing their data
Yeah.
from
The
Middle East to
reason
the.
the reason is not like they are from US or something. They say for AWS or GCP even, they say, "Okay, come to our country and set up your cloud provide, like set up all your servers here. We are fine with it." And now the things are changing a little bit. Earlier, I mean, if I talk about the last year, all the clients were like 100% on premise, but now I would say 80-20, like 20% is on the cloud, but still the servers are still in the kingdom itself. So that is the thing.
Awesome, man. I think it was a fantastic conversation. I think we are heading to the 1 hour timeline, which I wanted to close at. Anybody, any questions? If you have, maybe we just have a few minutes. Um, so please send me a request for the speaker. I'll add you to the speaker, and then maybe you can ask. If not, we'll close the session.
I think it was a wonderful session. I think, yeah,
Yeah, yeah. Just so I just wanted to share like how you can start with learning this, like how I started. So basically, like you can just get a GPU from any provider like AWS or Google. I mainly use these new cloud providers like Busty. There is a run pod. You can take a GPU for $2 per hour or $3 per hour. Then you can install GPU operator, which does all this installation like NVIDIA driver installation, all these device plugin installation. So uh, get a GPU, install the GPU operator. Then you have to install like Triton inference servers or VLLM, which we just heard about. So install at least VLLM or Triton, and then you can just add any type of LLM and host it. So I started with this. Like you get a lot of uh, errors while doing this, and you will learn a lot because you are actually doing things like hosting the LLMs. And if you are using Triton, you can host any type of LLM, like text-based, image-based. And if you are using LLM, you just need you can install a text-based. So I think that will be the best way to start.
Interesting. Same thing. So I mean, one quick hack around this area is something that I'm doing right now, which is to find the cheapest GPUs or the CPU based workload that's available. I did a quick search in Perplexity and it came up with like some provider in the US, I think in the Europe. It's 0.00, I mean like literally 2 cents per hour, which is the cheapest version of 4-core 8 GB system that is available. And literally it costs around $17 per month, I think, or I'm not really sure. I don't remember. I think you can use ChatGPT to ask and find the cheapest possible GPU workload that is available. Do not rely on AWS, GCP, or sometimes even Microsoft. These guys are obviously expensive. There are providers who are cloud providers who are relatively cheaper. Um, we can just give it a shot. I mean, like, if we really want to learn, we just buy it, use it for a week, and then you can delete it. You'll pay anyways per hour basis. If you want to try it on weekends, you can turn it on for, let's say, 8 hours, 9 hours, test it out, delete it. You'll eventually pay $2, $3, maybe max, and then you are fine with it. Like, this is the learning path, I think, especially because not every company will have their own GPU workload. This time it has to be personal money, or maybe you can just ask your company to, you know, buy these things so that you can learn and implement it in your organization. I mean, for those who are actually working. So yeah, so that's my input. Any questions? Any final thoughts? One final question, maybe to Zafeer and Anuj. Anybody?
Mutta, can you
Yeah,
share the GPU cloud that you were talking about?
It was not the GPU cloud.
The
I was
cloud
looking
provider.
for I was looking for the CPU only. I don't want to launch my instances in AWS. I searched for
Okay.
um, CPU based workload, 4 core, 16 GB is what I was looking for. And it gave me Head Hetzner Cloud,
Yeah.
HET. That's the one that I got. It's the cheapest cloud that is available. Maybe you can just, I don't know if this is true or not. Maybe sometimes even LLMs do not give you the right output, but it's
Yeah.
the cheapest cloud that is available is what I found.
There is one more. There is one more actually. It's called Rafe Cloud, right? Um,
Uh-huh.
so here, what you can do is basically sign up with your company's email. They'll set up an interview with you, like basically what you want to do, what you are trying to do is like. So if they're satisfied with it, they'll give you the machines for free without any cost and or something for a month, I guess, depending on like how you convince them. But that's one way if you just want to try it out.
Yes, Rafe, I know the CEO of Rafe.
Okay.
We managed to get into a discussion. I mean, like, I also got access to the Rafi Cloud, as you said, as you rightly mentioned. I got an
Yeah.
access where they allowed me to try it out, but I did not, fully expand at that point in time. Maybe I'll get back in touch with him and then ask for this once again and see how that goes. All right. Any final questions? We are out of time. One question we can take, probably one or two, maybe at max. And by the
Yeah,
way, this session is recorded. You can still play it if you missed it. Very good points were discussed. I highly recommend everybody to go through it if you guys missed it. And I really appreciate if you can share it for others as well. Um, yeah, Srikanth.
yeah, thank you for the opportunity. Currently I am working as a DevOps engineer, especially with respect to Kubernetes. I have a decent hands-on experience with Kubernetes, but I am completely new to this AI/ML model. So, in case any route path that I can follow. So maybe that would really help me to grow further with respect to the AML part. So any suggestions, any roadmap that I can follow
I
would be
think
really helpful.
this was already discussed in this. Maybe Zafir
Oh,
or Anuj can add if you can go through the session. Zafir, do you want to add anything here or
Yeah, Srikant. I think Srikant was the one question, right?
yes.
yeah?
Yeah, I think firstly get a GPU. Second, try to host an LLM. You can take a small LLM, let's say 8 billion parameter LLM or less than that even. Host the LLM directly on the GPU without Kubernetes. Then install the Kubernetes. Third step. Fourth, install the daemon set plugin. And fifth, try to host the LLM inside Kubernetes. I think this is the like decently enough good start to host the AI ML workload inside Kubernetes.
Yeah, Zafir, this is a very I mean, like Srikanth, this is very high level stuff. What
Yeah.
he said was detailed in a little bit in depth in the, space. It is recorded. Maybe once I end the session, might able to, listen through the important bits and then you can search on the LLMs to find more information, and then you can look through some videos. Obviously, there will be some set of videos which are already published. You can take one step at a time. There is no sharp roadmap with a set of tutorials saying, "Hey, this is how it needs to be done." Very new technology. Very few people know it. So I think we have to do this on our own, as far as I understand. But I'll be glad if somebody actually does a full length tutorial on top of it. But yeah, we have to explore on our own this time. That's my
Sure.
understanding.
Sure. Thank you. Thanks a lot for all the inputs.
All right. I think thank you, Muta. Thanks a lot for giving me the platform. I think if you could keep it every week, I think we could just even talk like casually about uh, probably the problems we face, and I'm all open for learning from you guys as well.
Sure. I will continue to explore more on this area. I'll share whatever I, kind of find. And I'm thinking about doing some sort of thing, live stream kind of a stuff
Okay.
on Twitch, directly streaming to YouTube kind of stuff, so that you can actually see me and the rest of the people. Let's say I maybe 3 or 4 people in a stream discussing about the things that they have done. That would be more interactive. Yeah, audio is a good thing, but I'm not really sure how to do this with a video. I really want to do it with a video so that people can interact with each other, see what they are doing and all that stuff. It'll be more interactive. But anyways, so I'll explore on this option. Maybe you guys can help me figure it out. What is the tech that is required to do this? Yes, we have Vertex.
I think
Hi,
Vertex.
here
Mona.
also we can do live, right? Live video.
I'm not really sure. I've not done it. Yeah, Vertex. Yeah, please
Yeah,
go ahead.
Martha. Good evening, everyone. As I actually we talked earlier, I'm Rishi. I got a job at Tech Mahindra at a very low base, but I started, and it's like more than 20 days. 15 20 days, as I was like very frustrated about like I will get like a like getting an opportunity or not, but still I cope up with a low paying job, but still people laugh that Infosys, Wipro, Tech Mahindra is nothing. You're fool. You're not getting Atlassian, Google, Amazon. But we know that we know like how's the market is. The market is bad. We are waiting for the right time, but still we are not with anything. Still we are not employed, and we have something. We have to be proud of that. So that's what I'm currently doing, and building something on my own, like apart from my job. So that's what I wanted to do. Always I'm doing that.
All right. I think Vertex. I mean, like you are placed, right?
Yeah, I got placed.
Yeah,
Yeah,
so that's all matters. So the thing that I mean, like I don't understand that you are asking any question, but my fundamental understanding is if you are getting a job, you are already in top 1 or 2%. There are 98% of people who are not.
but
I mean, like
but
graduates from
basically
2000.
basically in India, why people laugh? If you are in Infosys, like, people laugh. For LP, 6 LP, nothing. Amazon,
No, no,
Google,
no,
then salute, then
dude.
salute. Why it is like that?
I started with zero INR. I worked for a company for 1 year in 2008 recession. This is exactly what is happening now. It's getting repeated. I worked for 0 rupees for 1 full year just to gain some experience. It doesn't have to be that way. Some people will always point their fingers at you no matter what you do. It's that. The
And
world is like that.
I wanted to ask, I wanted to ask, like, some people have never seen any struggle in their life, but their first job was at Amazon. Is it a destiny or luck?
No, 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 man. It's almost all the time. It's the hard work. You don't see what is happening in their life. You don't know, man. You don't know how many hours they are spending, how many hours they have put in. It's cracking Amazon is fluke for maybe 1%. 99% it's hard work. Absolutely. I do not even, think about any other ways. You cannot get into Amazon without hard work. Or see, you must be a genius with, let's say, 200 IQ or something of that sort. You can still play around, chill around, and still crack. Still consider that as 1%. 99% is pure hard work, man. It doesn't happen
Yeah, because like getting into top product based company, it's all about DSA, and I have worked hard for that, like lead code, hacker rank, hackathons. But still, see, I was unemployed for 3 months, so I compare myself with a girl or a boy who got the first job at Amazon, still in layoffs time. But like I feel that if I know that thing, if I have done that thing, I should wait for some time. Even it's for 6 plus months, because like graduating in the May month. Currently is November. 5 months gone and 3 months of unemployed, it's not a sign of failure. I can still wait for 3 months, 4 months.
See,
Let's still apply with referral.
my thing is, if you have a job, you can always step up from there, as you are rightly thinking. You can still step up. Who knows, you'll get into Amazon, Google in the next month. So get something if you want to. Yeah, that's how I think. Harsh,
And like Musa, everything is going fine. Like 2 or 3 companies I'm getting interviews and I'm just like still not get the offer letter, but now I'm getting like top companies interviews. It's like that. And earlier, like before we talked in the space, in the last 3 months I was not getting anything. So how the luck and destiny changes.
it's subjective experience, man, really. Oh, we have my friend. I have a couple of my friends, Dhanush and Suman. Um, guys, like Suman is also working in this AI space. He's one of the best I know. I've learned Kubernetes. He was my mentor. He taught me so much. I'm always indebted to whatever he's done to me. Suman, anything from your side if you want to add for people who wants to get into this AI space, especially managing Kubernetes? Um, Suman, if you can just send me that speaker request, I will be able to add you. I don't know if he's even ready.
So like Mutha, like I want to ask something. I want to like add something in this AIML. So people who are starting for AIML work, AIMLs, like or into Kubernetes, whatever. So I say that like first growth, first no, as a basic person, we go through the documentation. Then after we go to GitHub, we go to see like, the projects. First of all, get yourself aware for the open source development. If you're in the open source development, the main thing is you're already aware about what things are going in the market. And the second thing is people will help you even if you are making something like building something on your own. Even it's a prototype, it's a startup, it's a product, it's a project. People will help you. People are very helpful in like if you're active on Discord, on on GitLab, on GitHub. So start with that. Start with basic. As you know that in Kubernetes, everything we know that in AI ML Python is must. People who started with Python, with PyTorch, or any framework, any technology, it's not like a relevant to any technology or any framework. But I can say that make yourself more involved into social media communities, into open source communities. As you are spending time on your projects, spend half of the time in that, spend half of the time in your projects. Both things can help you with that. And apart from that, everything is available on YouTube. Like you can ask or ping me for like a roadmap to get into that particular field, so I can guide you better with that.
Absolutely,
Yeah,
man. I think
that's what I want to
it
say.
was really helpful. Um, I'm not able to. I got someone in place. Someone, any suggestions for everybody?
Hi. Uh, Hey, hi everyone. Good evening, good morning from where I'm joining. Thanks for that. Am I audible?
You are someone. There is some disturbance, but I think you are audible.
Uh, okay, okay. Go a little bit on the quieter side. Thanks. I mean, Vamsi, like you started a nice space actually. It's mostly a lot of discussions happen around this. AI areas. And yeah, I mean, on the technology side, I can quickly share my thoughts. I mean, currently in our organization, we are kind of using AI workloads a lot on the Kubernetes side. So we are basically a private cloud platform hosting providers. So we do support different configurations and models of I would say, uh, NVIDIA AMD, whether we are doing GPU pass-through configuration or VGP pass-through configurations. Now, what I've seen actually typically since this area is still growing, so first thing is like you cannot get a direct documentation, and uh, And I was actually listening to, and some of the things I do agree that you have to like couch a bit lot on the open source GitHub side actually, because I have seen issues where the driver's installation fails because that driver probably is not supported with a specific version of the Kubernetes that we are running. So we need to update those drivers, and those are not clearly called out anywhere actually. And if you look specifically, why I'm calling out NVIDIA is because, as you know, right, NVIDIA is more popular these days, and most enterprise organizations are using um, the NVIDIA drivers for their enterprise AI workloads. So there are other providers as well. Having said that, but yeah, so yeah, again, I mean, there are many things to be taken into consideration, like while using that. Like I mean, I was just looking into some of the new features that are coming on the latest Kubernetes 1.34, and one of them being DRA, which is the dynamic resource allocation, and this is one of the game changer, I would say, for running GPU-based workloads. Because prior to that, the only problem was that when we use different OEM drivers, you have to make a lot of customization and changes specifically to run them. And with DRA, it is becoming a little bit easier in terms of what is the hardware requirement, how the scheduling has to be done, and specifically with respect to the deployment, right? So that becomes a lot of helpful actually. Actually, I mean, I have never tested that. At this moment, we are not running, to be very honest, with 1.34 on our production environment. It's still on 1.33, but I was just running some of proof of concepts, and I have seen some performance improvement using VR actually. So that is one good thing. So yeah, I mean, uh, the thing is that I'm not going much into the development side because uh, that is something which I am not so familiar. I'm also looking a little bit onto that area, but most of the platform engineering aspect where we want to run the GPU workloads, it almost is something where we need to still search for open source documentations, or maybe any specific implementation that was done as a use case, something like that, right? So we need to basically look into that. And yeah, I think that should get streamlined with more and more some feature as it comes. It will be more streamlined. But yeah, I think that is a good learning, I would say. You get to look through a lot of documentation. You get to learn a lot about how slicing works within the GPU cards, how the profile configuration is done. All those things actually is very interesting thing, I would say. Yeah, so that's all I just wanted to add to that as Vamsi requested. But I think, yeah, that's all from my side.
All right. Thank you so much, Suman. I really appreciate that. First of all, you joined. I really thankful to that, and you added something on top of it. I'm sure multiple people will go through this session. This is a recorded session. I'm expecting at least 500 people to watch it and try to understand what's happening. We also had a very good conversation with Zafeer. He was able to share what his experience is, and we also had Anuj who is able to share his experience. Any final words? Dhanush is my colleague. We work in the same company. I asked him to join at 6:30 and he thought this session starting at 7:30. But anyways, any final conclusions, Dhanush?
Hi, MC. I didn't join the initial session, so I was not sure about the discussion, what happened, but was listening to what Suman was saying. So, as of currently, when we deal with this AI and ML workloads, as far as I see, there's no any specific thing like this is the best practice because it's keeping on evolving. Like it is like 2 months past, like 3 months past, things are keeping on evolving things. So there's no like specific like this is the best approach which we are following. It will be for next 6 months. We cannot say. So things are keeping on changing. We have to keep adapting. That's the only point which I want to add. But haven't worked much on this workloads and Kubernetes. Both things to explore. That's the thing. That's solving.
Yeah, this is
Just
all
to add
about
one
that.
point from my just to add one point from my side, I'm not sure if you all know, like in this last KubeCon that happened, there is a separate AI conference on Kubernetes. A specific group has created, which will be looking, or basically which will be contributing to all the tools within the AI ecosystem within CNCF, and that would be quite helpful. I think so. I mean, we would definitely have some kind of um, um, technologies through which we can go through and use those tools specifically for running AI workloads. Actually, so there's a complete different AI governance model which is being set up now, actually, and probably that would also enable having certified AI compliances and all those aspects. Actually, you know about like responsible AI and all those aspects. So yeah.
Yeah, any resource that you talked about, maybe you can just you know pull it out, and if you can, maybe paste it here, or you can send it to me maybe in chat, and then I'll be able to share it with the community. It's up to you. Even if you share it on you've already shared it on your timeline somewhere, maybe you can just put me the link, and I'll be able to repost for everybody so that they can
Yeah,
take it from there.
sure.
All right.
I'll do that.
Sure. All right, guys. I think we've had great conversation. This is a fantastic space that happened after a long time. I highly recommend you to watch it if you have not watched it. Um, that's all. Thank you so much for being a part of this. And if you have any further questions, maybe you can just send me a DM, and then I'll pass it on to Zafeer, Suman, and Anuj, and see if we can get any response from them. All right. Thank you so much, guys. Have a wonderful day. Bye.